Good afternoon, and thanks for joining us for today's webinar, Pythium Disease Management, presented by PBI-Gordon and taught by Brian Aynardi, Ph.D. My name is Lisa Wick. I'm the Senior Manager of E-Learning Programs and will be today's moderator. A couple of quick housekeeping notes. We are recording today's event. That access will be sent to you as part of the follow-up email. Your audio is muted in this system, but we encourage you to ask questions as you go along. You can do that in two ways. On the GoToWebinar Control Panel tab that has a little orange rectangle at the top, you can see at the bottom there's a raise hand button. If you click on that, I can unmute you at an appropriate time to ask your question. Or when you click on that, you can see the different parts of the GoToWebinar Control Panel. Which one is the question answer box. So you can type questions in there, or you'll also see the handout area and you can download the handouts that are available to you. Today's session is eligible for GCSA external education points, and at the end of the program, we'll give you a code that you can put into the GCSA website. We hope you find today's webinar valuable. It's brought to us in partnership with PBI-Gordon. With a full line of herbicides, insecticides, fungicides, growth regulators, and other products, PBI-Gordon Corporation is a national leader in the professional turf and ornamental management industry. We thank them for their support of this and other GCSA programs. Today's presenter is Brian Aynardi, Ph.D., is the Northeast R&D Scientist and Manager of University and Contract Research for PBI-Gordon Corporation. He earned both his bachelor's in turfgrass science and his Ph.D. in plant pathology at Pennsylvania State University. Aynardi worked as a research technician at Penn State prior to joining the team at PBI-Gordon and resides in State College, Pennsylvania. Please join me in welcoming today's presenter, and I'll turn it over to you, Brian.
Okay, thank you, Lisa, and thank you to GCSAA for allowing the opportunity for me to share my time and talk a little bit about my experiences with Pythium disease management. I'm going to shut my camera off here. I figured I'd be on just so y'all could see what I look like. But if you have questions along the way while we're going through the presentation, I'd ask, because I have a fair amount of slides, that you kind of hold those to the end, or at least send it through the message medium to get over to Lisa. So without further ado, we're going to go ahead and get started here on this presentation. So, Pythium disease management. I hope none of you have had situations where you see what's going on in the background here, but it is a real possibility, particularly when you have environmental conditions very similar to what we're experiencing right now in the Southeast and soon to be Mid-Atlantic and Northeast US with the amount of rainfall that we've had both this year and with the incoming tropical system that's moving north and eastward. There's going to be several different types of Pythiums we talk about today. The primary ones we're going to talk about are on the left here. If you see this orange discoloration, this is Pythium root rot, which is a major problem of creeping bentgrass or creeping bentgrass mixed Poa annua greens. And the other type will be on the right, which is Pythium foliar blight. We're also going to talk a little bit about Pythium root dysfunction, which maybe outline some of the criteria with that disease, which maybe you don't know about, because it isn't as widespread, I don't think, as many people think it is. And we'll talk about why that is here in a little bit. So we're going to start off with the participant poll here to see what type of turf you all are managing. And while you're answering, the reason for this is, you know, if you're managing ultra dwarf Bermuda grass greens, as we talk about Pythium blight, that's going to be a little different than those that are managing bent grass or bent Poa greens. Same thing with Pythium root rot. So go ahead and see what everybody's managing here, primarily on their putting greens, and we'll go from there.
Okay, closing the poll in 5, 4, 3, 2, and this is what your particular audience is managing today.
All right, I'm going to guess that the other is either Seashore Paspalum or maybe even Zoysia, who knows. But this is nice because there's a nice mix of cool season and warm season grass in here. So hopefully I'll be able to provide information that helps those of you growing both cool or warm season grasses out with Pythium disease management as we go through the presentation. Before we get into specifics with Pythium disease management, I kind of wanted to cover a few of the just major concepts of plant disease because I'm going to use a bunch of different terminology that for me is kind of normal, but I understand everybody doesn't use these words all the time. So I figured some of this would be helpful as just a review, as many of you are assistant superintendents. So what is plant disease? Well, plant disease is the visual result. Okay, so you're seeing a reaction of a dynamic, sustained interaction between a susceptible host, a virulent pathogen, which is mediated by conducive environmental conditions. These three components make up what we call the disease triangle, which is going to result in the amount of disease you have. For instance, if the host plant that you have is, let's say, perennial ryegrass, and the pathogen you're talking about, just for example here, would be summer patch, right? Perennial ryegrass is not a host of the summer patch pathogen, so you're not going to have any disease. To the contrary, if your host is Kentucky bluegrass, or if we want to talk about Pythium, you want to talk about young perennial ryegrass, and you have the pathogen present in the soil and environmental conditions are there, you're going to have a lot of disease and it's going to occur very quickly. So always remember, in order for disease to occur, right, no matter what time of year it is, what the host is, you need to have a host that, for one, is infected by a certain pathogen that you're worried about, and two, when you have that host there, you need to also have conducive environmental conditions in order for that pathogen to infect the host plant and subsequently cause disease. I'd also like to tell you that what we typically observe, right? So when you're seeing something, that's disease. So when I say, oh, it's, this fungicide, for example, controls dollar spot, okay? You're not actually controlling dollar spot with a fungicide. You're controlling the pathogen that causes dollar spot, right? The disease name is basically made up after what you see visually as a result of infection. Okay, signs and symptoms of disease. I hope by now all of you have heard these terms used, but a lot of times they're used loosely and they're not very specific. So what do they really mean? A sign, okay, is a visible structure of the pathogen that's readily observable on affected plants. Examples would be aerial mycelia, which you'd see a lot of with Pythium blight, sclerotia. You'll see these particularly with gray snow mold, and then mushrooms, obviously something you see with fairy ring. Symptoms, all right, are the physiological response of a host plant due to attack from a pathogen. These can be things such as lesions, chlorosis, patches of grass that's dying, blight, which is a quick, rapid death, and also necrosis, which just is death. So examples of signs of a pathogen. Here are some sclerotia of the gray snow mold pathogen. Here are a cervuli, which you'd often find with anthracnose. There's a mushroom or puffball you'd find with fairy ring. Aerial mycelium, this in particular is from Pythium blight. And also aerial mycelia or sclerotia that you'll see with red thread or pink patch. So those are all signs. Those are actually seeing the physical pathogen. So symptoms, right? Here's brown patch, and you can see that smoke ring. It's been a banner year for brown patch throughout the US, so I'm sure many of you have been seeing a lot of this. Dollar spot is another one, right? Lesions, that's a symptom, is a lesion. Okay. Dollar spot infection foci, along with brown patch, again, those are symptoms. You're seeing the result of infection of a host. And this is the start of some Pythium blight, which is also a symptom. Okay, now that we got those two down, just because I'm going to use the word sign and symptom a little bit throughout this talk, I want to go into what causes Pythium diseases. So overwhelmingly in plant pathology in general, and particularly in turf, the majority of diseases that we see are caused by fungi. Many people like to think of the Pythium diseases as being caused by fungi, primarily Pythium blight, because it forms that aerial mycelia, which looks like many other pathogens, but they're actually not true fungi. They're oomycetes, and some people like to call these water molds. So why is this important, and why am I telling you this? They produce oomycetes, that is, produce mycelium spores, which just look like regular true fungi. Okay, ascomycetes and basidiomycetes would be your true fungi. Some of the differences are more academic. You know, if you have a scope at your facility and you're looking at stuff, the mycelia of Pythium will not have any septation or cross walls in it, okay? One of the more important parts is that oomycetes lack chitin in their cell walls. Why is that important? Well, some of your fungicides go after chitin synthase, okay? Another thing is that they don't form ergosterol in their cell membrane. So ergosterol helps regulate, you know, water and materials coming in. And there are a lot of fungicides actually that prevent ergosterol formation, and that's how they prevent diseases. They're called DMI fungicides, right? Your sterile biosynthesis inhibitors. So it's kind of important to know, any of you that may have tried to spray a DMI on a Pythium disease and it didn't work. Well, that's why, because it targets a site, or those DMI fungicides target a site that you don't have in oomycetes or in the Pythium species. Another issue about Pythium species and why they're problematic is that they reproduce sexually. This is important because of genetic recombination. It can allow for a much faster fungicide resistance to develop as a result of that. They also form a lot of spores, and again, in a lot of aerial mycelia very quickly. So that's why you have a higher potential for fungicide resistance to develop with these pathogens. Oospores, which you can see here on the right, this is some plant material, this is root material right here. And you can see a whole bunch of oospores. And these are characteristic of what you would find if you're looking at your roots and your turf on your greens looks a little bit orange or irregular in color, and you find a lot of these, then that would be a diagnosis for a root Pythium disease. Oomycetes are very tough to control, partially for what I outlined above. Not all fungicides are going to control these types of pathogen, and it's an economically very important pathogen. It's actually an oomycete, Phytophthora infestans, is what caused the late blight of potato. And there's also another Phytophthora disease called Phytophthora ramorum, where is the pathogen. It causes the disease sudden oak death out on the West Coast, which has caused a tremendous loss in oak trees. So oomycetes are very important, but predominantly what you need to know about this is that they're different from true fungi, and the differences from true fungi and oomycetes makes it tougher to control oomycetes. Okay, so first we're going to start off when we're actually talking about diseases. This is what you all really want to hear about, not a lesson in fungal genetics or information, but what do you actually need to look for? What environmental conditions are there? And how do you control the disease, most importantly? So I hope all of you are familiar with, or at least have seen, Pythium blight. This is damage you'd observe with Pythium blight. Very prolific cottony aerial mycelium, which you see around the edge of the patches. You might also see some dark smoke rings at the edge of patches. Basically, where you see mycelia active, or those dark smoke rings, that is where new plants are being actively infected, right? So here in the middle where you see death, you're not going to see much aerial mycelium. It's where you're seeing active infection and death is where you're going to see that. Also, this picture isn't really great about showing it, but anytime fungi or fungal-like organisms cause plant disease, and the reason not is this is actually a fungicide trial. You can see the square here. But fungi grow out radially, right? So that's typically why you see a circle and stuff moves outward, okay? And as you move outward, you're going to see different levels of infection. That's also why you see fairy rings and circles. So Pythium foliar blight, this is one of the characteristic first symptoms. You'll see a bunch of cottony aerial mycelium. You can see some more up here flecking off that leaf surface. Typically, it's going to be a smaller patch, or you might see oily, darker area. But again, it's going to be a smaller patch, probably about the size of your fist. So on cool season grass, and that's specific to cool season grass, what I just said, you're going to need the following environmental conditions in order for Pythium blight to develop. Those of you who live in the Northeast or Mid-Atlantic and have had these temperatures seemingly for a long period of time lately, you need 85 degrees or greater during the day. and you need greater than 65 degrees at night. Now, these are your textbook numbers. If it's 64 or 63 at night, that will probably be sufficient. If it's 84 during the day or 95 during the day, those are also going to be sufficient. You also, in conjunction with those specific temperatures, need greater than 90% relative humidity for 14 straight hours. So when does that happen? Typically, that's going to happen in a situation where you get late day thunderstorms or a really heavy tropical system or weather system moving through. You have leaf wetness for an extended period of time, and then you get into night. The leaves don't have a chance to dry off, and because of that high relative humidity, the water doesn't go anywhere. It's really muggy out, and that's when you can expect Pythium to occur. On warm season turf, it's a bit different, right? So you're not going to typically see Pythium foliar blight on Ultradorf Bermuda grass greens in the middle of summer, mostly because it gets too hot, especially places like Florida, where you can be over 100 degrees Fahrenheit, because Pythium really doesn't grow well above that temperature. But on warm season grasses, particularly greens, collards, and fairways, you're going to find that in cooler, wet, humid conditions where cloudy conditions persist in the fall and spring, just like we had, down in Louisiana and is moving through the southeast right now. Those are weather conditions that are prime for Pythium blight to develop. Oftentimes, you're going to see Pythium blight develop in Ultradorf Bermuda grass, and it's going to look very much so like leaf spot. They occur around very similar times. The initial symptoms can look very close to one another, but you want to make sure that if you have a big system moving in, a big rainmaker, and temperatures are going to cool down, that you're protected in those situations. So symptoms, they're initially observed as water-soaked lesions or pockets. The dark, oily texture to the leaves gives it the name grease spot. Another symptom would be that it quickly kills large area of turf. That's what blight means. Signs of the pathogen are, of course, the mycelium, and that's why it gets the name cottony blight. So, talking about those conditions, this is from a few years ago. I pulled these slides, but this will give you an idea of what I'm talking about. I'm up here in State College, which typically tends to be one of the cooler, more temperate areas in the Northeast. But if you look in the DC metro, the Philadelphia area, these are temperatures at 5 a.m. And you're talking up in the mid to upper 70s. And if you look at relative humidity at that same time, it was near 100 everywhere. So this was a period where it was prime for Pythium foliar blight to develop on cool season grass. Again, you need it above 65 degrees at night and pretty much everywhere in the Northeast, with the exception of the mountains. You're seeing well above that. And you also have greater than 90% relative humidity for an extended period of time. This is a couple days later. Again, this was a bad little spell where there was a pretty good Pythium outbreak. Again, you can see southeastern PA. This is 5 a.m. temperatures, almost 80 degrees in the Philadelphia area. And again, relative humidity was extremely high. And in this consequence, it was not good for superintendents growing grass. Again, this was that same period of time, whether they're worried about foliar blight, but also root rot. You can see the amount of rain just over a short period of time, and it was a record-setting year for many places in the Northeast. So this is one of my favorite pictures that I took of Pythium blight on a golf course. You can see the rough here. This is they have bent grass fairways. And why I like this picture so much is it shows a number of different things about Pythium blight. First, you're going to find Pythium blight because of the requirements with high relative humidity along areas where you don't have much air movement, right? So whether you're growing Bermuda grass greens or bent grass greens or what have you, you're going to find Pythium blight develop in areas with low movement, right? So this is on the side of a mountain on a north-facing slope, so it's going to dry out much slower. But you can see that Pythium is going to move down the hill, okay? So it's moving with the water, all right? Another neat thing about this picture from a pathological perspective is right here in the center, that's where you're finding everything that's just completely dead, okay? This stuff right here, not coming back. But what you see along the sides here and right at the bottom of your screen are these oily, orangey, off-colored areas. And that's where active infection is occurring. And like I was telling you earlier about it moving out kind of in all directions, what you're also going to notice when you see a disease, and this is helpful for you regardless of what you're looking at. If you're out and about and you see something that looks like disease and it all looks like this, right? It's all dead. It's probably either the remnants of a disease or it is abiotic or something caused by something else, not a pathogen or a fungal pathogen. What you see with real disease is you typically see dead or dying areas in the center, and as you move away, you start to see infection or plants dying along the edge, and it goes from an area of high concentration to low concentration as you move out. So if you're ever concerned, if you see something that's a perfect circle, you know, that's about 4 feet in diameter in your backyard, it's just dead grass. All of a sudden, overnight, perfect circle, dead grass. It's probably because you had a pool there or something else sitting above the ground that resulted in turf loss. But if you see this gradient moving out with infected leaves and healthy leaves, and then moving in more and more death, that's more characteristic of a plant disease. All right, we got another poll here. So if you get Pythium blight, on what type of turf and where? Is it ryegrass in your rough and fairways? Is it bentgrass tees and fairways and greens? Is it Bermuda grass rough or your ultra dwarf greens?
While they're voting, I'm just going to tell you the oomites you said were responsible for the Irish potato famine, which is why my mother's people came to the United States from Ireland.
There are a lot of, in fact, that's why most of the Irish immigration occurred, was the late blighted potato, the famine back in the 1840s. So.
And now I know more about why it happened. And
Yep,
you
there you
learn
go.
something every day, Brian. Okay, closing the poll, folks, in 5, 4, 3, 2, and here is what those answers look like.
Okay, so most of you are worried about it. I'm guessing the 17% on the greens with Ultra Dwarf, you probably see that in conjunction with leaf spot. I wouldn't be surprised if any of you haven't seen that lately. And if you haven't, it will be coming here in the next few weeks and months. Those in cool season grass, I'm sure you've probably had a tough year. Maybe with, you know, not Pythium necessarily that's going to look like this all over your course, but especially in lower areas, green surrounds, places where water doesn't drain. I'm sure you've had your fair share of that, fall armyworm, and every other problem that 2021 has provided us with so far. So how do you control Pythium blight? Well, Pythium blight is one of those diseases that you really need to apply fungicides preventively. The good news is whether you're in cool season grass and you're going to look for that greater than 95 or greater than 85 during the day and greater than 65 at night with, you know, prolonged relative humidity that's really high, or if you're in warm season grasses where temperatures aren't as important, you know, really as it's greater than in the 60s or higher, but you're going to have big rainmakers, you know the environmental conditions you need to look for. But when you know that that's the case, you also need to be prepared to go out to spray fungicides preventively. Okay, in some cases, like we'll talk later on, you know, curative, quote unquote, curative applications can be helpful. But with Pythium blight, if it's dead, you're going to be reseeding. And since we're talking about fungicides and curative control versus preventive control, I'm going to let you in on a little secret if you all weren't aware of this. There really is no curative fungicide. I'm not really sure where that came from originally, but what you're doing and the way our fungicides work, as we'll talk about in a minute here, is many of the current fungicides, they're not actually fungicidal in nature. What they do is they're absorbed by the fungus or the fungal-like organism in this case, and they slow down a metabolic process. Okay, so it's not like it immediately stops the fungus. It takes time for the fungus to absorb it and then to break down that part of the biochemical process in the cell, and then it will stop infecting. So really, in many cases, when you're talking about a curative application, what's really happening is you're stopping infection and you're allowing the plant to recover. However, and that's okay with many diseases, but with the case of Pythium blight, because it actually kills the crown and kills the entire plant, that's why a curative application in this instance will not be beneficial. So just another couple of reviews here. I just thought, going over some of this information would be helpful from you from a fungicide control standpoint, even if it's not with Pythium. So we got two types of fungicides, right? There's contact and penetrant fungicides. Contact fungicides, as the name implies, they don't enter the plant. They contact and they stay on the outside. Examples of this would be chlorothalonil or daconil, fluazanam, Secure, and mancozeb 4 would all be examples there of contact fungicides. Coverage is critical because they protect the plant from protect the plant from infection. So it's important that you cover as much of the external part of the leaf as you can. However, like I said, they're contact. They don't prevent anything that's already going on inside the plant. And remember, just because you don't see disease symptoms, that doesn't mean that plants nearby where you have disease occurring aren't in the infection process. It just may mean that you don't see symptoms yet. Contact fungicides, because they stay on the outside of the plant, really only provide 7 to 14 days of prevention from infection from a pathogen. By the end of 14 days, typically you're reapplying. They bind firmly to organic matter, so they have limited to no control of root diseases. And they limit the spread. The reason you put them in like a conjunction with a penetrant fungicide or in the tank when you see disease out and about is because it helps limit the spread or limit new infection to surrounding healthy plants. Penetrant fungicides, conversely, enter the plant. Examples of these would be your demethylation inhibitors or your sterile biosynthesis inhibitors, or we prefer to call them. Your QOIs or strobilurins, the SDHIs, the quinone id-side inhibitors, which are very closely related to the quinone outside inhibitor, the strobilurins, dicarboxamides, polyoxins, and basically everything else we use. Within these types of fungicides, the penetrant fungicides, there's 3 different types of movement. One is localized, okay? That means wherever it's absorbed, it's going to stay in that general vicinity. The second type, and this is the majority of penetrant fungicides, are acropetal. They go up the xylem, right? So wherever you get them on the plant and they're absorbed, they're going to move up from there, okay? Systemic, there's really only one systemic, meaning it moves up the xylem and down the phloem, and the only one that we have in turf right now is aluminum tris or Chipco signature. New research shows that light watering in of penetrant fungicides doesn't seem to have an effect on efficacy, predominantly because of ones that are acropetal, but also with some of your localized penetrants, the work done on these fungicides when they look at phytomobility or how they move in a plant, they're typically done on larger ag crops, right? So if it moves, an inch or 2 in a soybean, that might be considered localized in movement. But if you're moving 1/10 of an inch on a green or even 1/2 an inch on a fairway, I mean, essentially, even though it's technically a localized penetrant, it's really probably, in our case in turf, going to be efficacious. The only issue I would see where you could be concerned with localized penetrants, something like Segway, would be if you got 3 or 4 inch height of cut ryegrass and it immediately rains at the time of application. That's probably one situation where it's not going to provide the coverage you need. And just so you all know, another interesting tidbit, only 5 to 50% of penetrant fungicides are actually absorbed by the plant, and most of them only remain in the plant for about 14 days. Even if they provide extended control of pathogens, most of them are typically gone around that 14 to maybe 20-day period. A lot of your localized penetrants also exhibit what we call translaminar movement. Sorry, I clicked there. I'm going to go back. Maybe I'm not, but that's okay. Translaminar movement essentially means that if it hits the, the adaxial leaf surface, okay, so the top leaf surface, it will actually move through apoplastically through the cells and to the other side. So it will also provide protection on the abaxial leaf surface. So again, many of the localized penetrants, things like insignia or pyroclastrobium, segue or sizofamid, those have translaminar activity, as does, I believe, trifloxystrobin. Okay, we got another participant poll for you here. Now that we know that basically half of you are on cool season and half of you are on warm season, don't worry, I won't tell anybody what you said, but I'm interested to see what you're all using for Pythium diseases. And you can go primarily for this one for blight, since we've been talking about that so far. I will say, while you're finishing up your voting, the reason I only have aluminum tris on here, or signature, versus just quote unquote phosphites, is aluminum tris has labeled fungicide activity. Another example I could have put in there was mono and dipotassium salts of phosphorus acid, or a product like a peer. But just your general phosphites that you can often buy that are more fertility based, those don't necessarily always have a fungicide label on them. So that's why I was a little more specific there with that. So I think we're probably good here, Lisa, if we want to wrap up the poll. Okay, so there's a lot of you on a signature type program. Fair number with Banol, fair number with Segue, fair number with Subdue, fair number with Strobies. I'm actually going to say this is very encouraging. It's good that there's such a large number of products in there that you're all seemingly using. I would encourage you, because of resistance issues, all of these products have their place in Pythium control. Some are better with blight or root rot, some are better with root dysfunction, but generally speaking, rotate through those different groups so that you are on a good resistance management program. So Pythium,
and Brian,
blight,
I'm
yes.
going to thank you for mentioning the label, because the label is the law. And so we have to know, for wherever it is we're located, what that product label says we can and cannot do.
Yeah, that's a great point. Always follow the label. And there's a reason we have rates listed on labels. You don't go out and use sublethal rates below the label rate, even if it looks like it's working for you. Don't go below that, because you're going to be a breeding ground for resistance. Cultural practices are really important for Pythium foliar blight. You can probably reduce fungicide use with this particular disease, especially if you employ a number of different cultural practices. First, increasing airflow. I'm sure all of you, or many of you, have at least interned or worked at a place where you set up fans in the summer, particularly transition zone. If you're trying to grow bent grass, reduce free leaf moisture as much as you can, even if it's watering, lightly irrigating in the morning to knock dew off. That's really important. Pruning trees to increase airflow, but also pruning trees to increase light. That's going to help burn off the water faster and reduce that relative humidity and microclimates, right? So if you even look at this picture, yeah, you got the fan pointed here, but if this area is, let's say it's shaded all morning long and it's wet all morning long and you got high relative humidity, you might be fine here, what you're employing with your cultural practices, but maybe not so much here. Improved drainage, obviously, this is a big issue with Pythium diseases. You just need to make sure you got good drainage. You don't have free water lying around. Enhanced plant genetics. Genetics are great with plants. You can reduce the severity of diseases, but I think it's important that you realize that just because it says it's really good at preventing, it's a cultivar preventing a disease, that doesn't mean it won't get the disease. It just means compared to other cultivars, it's probably not going to get it as severely. And then also fertility management. You want to make sure that you're not too juiced up on quick release nitrogen, particularly for situations with Pythium foliar blight, regardless of whether you're on cool or warm season turf. Okay, so fungicidal control. This is one of my favorite pictures showing fungicide control because it's really neat. It's got different stages of the disease at various places. Active aerial mycelia. This plot right here happens to be the active ingredient segue. 14-day intervals are recommended for controlling Pythium diseases, and this is going to be a constant theme for the rest of the presentation. Don't try to push intervals. I know they're on labels. I know they're on PBI-Gordon labels. I know they're on other product labels. You can achieve 21-day control with a variety of products for blight, but it is really all about when the disease comes in. And when I say 14-day intervals, the best control, the most consistent control, the control I've seen without breakthroughs occurring is when products are applied at 14-day intervals. For the PBI products, Segue, half a fluid ounce on a 14-day interval, it's phenomenal. Same thing with Union. Union's our new fungicide that has azoxystrobin in it. Propamacarb is Banol. Banol is very, very good on Pythium blight, particularly at that 2-ounce rate. Mefenoxam or Subdue Max. Again, great product. You want to be at that 1 fluid ounce rate. Talk a little bit more about mefenoxam here in a minute. Strobilurins, these are decent on blight. If you're going to do a strobe on blight, you probably need Insignia at the 0.7 fluid ounce per thousand rate. Or if you wanted to use something like Fame or Heritage, you want to go with the higher rates too. Phosphites are good. They're great rotational partners. They're great early in the season. If you have the intense environmental conditions that are going to remain there for more than a day or two, phosphites are good early on. They're good as part of a program, resistance management program, but you're going to need more of a heavy hitter like something up here if you have environmental conditions that remain conducive for an extended period. Again, with blight, they have to go out preventively. Do this in 1 to 2 gallons per thousand carrier. Don't go less than a gallon per thousand carrier with fungicides. I'm sure some of you do it, and I'm sure some of you are fine. Across the board, what you need with fungicides, they're different than herbicides, right? And the way they work, you need adequate coverage, which is why I would say don't go less than a gallon ever for anything. And with this, with foliar blight, it needs to remain on the foliage, obviously, because that's where the pathogen is causing infection. Just a little quick thing here about Segue. If you're not familiar with this product, the active ingredient is cyazofamid. It's a quinone inside inhibitor, so it's FRAC21. So those of you that are doing good job with resistance management, this is the only fungicide or active ingredient, I should say, from this particular fungicide group. It is very close in how it works to the quinone outside inhibitors or the strobies. They both shut down cellular respiration inside the mitochondria, but there is no cross resistance between the two modes of action, even though they're very similar in how they work. We don't know of any resistance to Segue right now, so let's keep it that way. Make sure you follow the label and the recommended intervals. It's a localized penetrant with translaminar activity. Again, that means it stays in the general vicinity of absorption. For root diseases, it needs to be watered in immediately after application, okay? Don't wait. You've spent a lot of money in order to make an application. It has to be watered in immediately. And here are the labeled rate ranges, which you can find on the label for those diseases. Union fungicide, as I mentioned also, this is kind of, it takes the power of Segue or cyazofamid and then adds in the versatility and the broad spectrum applications of azoxystrobin, which is your group 11 fungicide. As I mentioned, there's no known resistance, cross resistance, I should say, between these two groups. So it's really a nice dual mode of action product for your Pythium pathogens, but also things that you're going to see that time of year. So let's say example would be, depending on when you make your application, if you're making a preventive application for summer patch, right? Or preventive application for Pythium root rot, it's a great time to make an application for summer patch with this product. You're always going to find, of course, brown patch in cool season turf. At the same time, you're going to find Pythium blight. Anthracnose, the strobe in there is going to help you out on anthracnose. We've seen some great results on fairy ring because of the azoxystrobin. If you're looking for a fairy ring program, start off with pedigree, which is flutalanyl early in the year, and follow that up with Union or Segway, right? That's going to be a great Pythium root rot control program, but also with the azoxide, it'll help you with farriering as well. This product, because of the broad spectrum abilities with it, and because of the superior Pythium control, I like to tell people, hey, 7 to 10 days before Memorial Day, July 4th, and Labor Day are all great times to incorporate this fungicide. So cyazofamid, that active ingredient I was talking about, why is it special and why is it so effective against Pythium species? Well, it controls all the different types or parts of the life cycle of Pythium species. So zoospores, oospores, which are sexually reproduced, also mycelia and zoosporangia. So that's why it's really effective. And zoospores, again, are those motile spores that move with water. That's why it's so effective in controlling Pythium diseases. I mentioned fungicide resistance a few minutes ago with mefenoxam. I'm not picking on mefenoxam here, but this is actually a great resource. If any of you have a comprehensive guide to a practical guide to turfgrass fungicides, written by Rick Lattin. It's an APS book. They just put out the second edition a couple months ago. It is a phenomenal reference. I reference it a lot, and he's got a lot of great stuff in there. Talks about a lot of the things I have today, actually, regarding fungicides, generally speaking. But when you're looking at fungicide resistance, and you're going to look at the combined resistance, for example, what pathogen am I controlling versus what fungicide am I using, right? There's 5 fungicide groups that are greatest at risk for developing fungicide resistance. Those are the benzimidazoles, or your thiophanate methyl, dicarboxamides. Of course, the only one we have now is iprodione in that group. The phenylamides, all right, or phenylamides, however you want to pronounce it, metalaxyl and mefenoxam, which is Subdue. The SDHIs, I'm sure you're all aware the SDHIs aren't looking so great on dollar spot in many cases anymore. Example there would be boscalid, and then your strobilurins, or the QOIs, example there would be trifloxystrobin or fluoxystrobin or pyraclostrobin. But anyway, you take your pathogen of interest, right? And in our case, that's Pythium blight. Its biological risk is among the highest. So these pathogens, or the diseases, or the pathogens which cause these diseases, are greatest at risk for resistance. So anthracnose, dollar spot, gray leaf spot, it's been a great year for gray leaf spot too, Pythium blight and pink stone mold, right? Those are the pathogens or the diseases which are most likely to have resistance develop among their pathogens. So if you're using a product with or you're looking to control a disease that has a very high biological risk, and you're looking to control it with a fungicide which has a very high risk for resistance to develop, you're going to have a very high combined risk. And that's the concern with using strobilurins and also phenylamides for controlling Pythium blight. And as you would guess, Pythium blight, one of the pathogens that causes it, Pythium fannidermatum, there is documented resistance with both the phenylamides and also the strobilurin fungicide, which is really no surprise. And we're not going to use any of these other classes on Pythium blight, which is why you don't see other things listed here. But anyway, it's a great reference for you, regardless of if you want to talk about Pythium diseases or just looking at different active ingredients as to where they stand. But you can see here, as I've talked about some of these others, propamacarb and cyazofamid for controlling Pythium blight, you have a reduced combined resistance risk than if you're using products like mefenoxam or strobilurins. This is, again, not to pick on mefenoxam, it's a great fungicide in many cases, but in this instance, you can see we're comparing it to Union. This was at Rutgers, pretty good at Pythium blight occurring, and you can see that there was a loss of control with this particular scenario with mefenoxam. So just be cognizant of that and know that it is out there and it is possible, particularly with mefenoxam and the strobies. This is from that trial. On the right here, you see non-treated area. This is Union at the low rate on a 14-day interval. This is Union at the high rate on a 21-day interval. Again, this is entirely acceptable, looks great. Just from everything I've seen over the years with all the Pythium products, shorter interval at the lower rate, particularly with Segway and Union, tends to be the best ticket. This is at Penn State. They inoculate and put a tent over. You can see this non-treated. It's probably not real life conditions, but this non-treated is 100% dead almost. And here is Union right next to it at that low rate on a 14-day interval. and you can see the level of control that's there. There's no disease in it. I was talking about pre-mixed products. In particular, I was mentioning Union, which is what I'm going to show you a picture of here. But pre-mixed products in general are great because you pick up other things that maybe the initial active ingredient doesn't, right? So I told you Segway is phenomenal at controlling Pythium root rot, but if you look here, Segway's not so great at controlling brown patch, and here's the non-treated control. But when you have a pre-mixed product that has something like azoxystrobin in it, you're going to get control of that as well. So it's really important to look at those pre-mix opportunities and see what maybe they can do for you. So we'll move on now to Pythium root rot. This is another huge problem. As you can see in this last slide, again, one of my favorite pictures, lots of disease. You can see the non-treated checks in this trial, but looks really good in these treated areas. So Pythium root rot, it's caused by various Pythium species. There are a number of different species that cause it. It's problematic on bentgrass and Poa annua greens. There's no specific temperature requirements that are required with this. It's not like Pythium blight where, you know, on cool season grass, you need this, this, and this, and this, right? Basically what you need is water and heat. You need significant rainfalls in order prior to disease development. It prefers waterlogged or poorly drained soil, so a lot of times you're going to find this on push-up greens. The infection process takes place most frequently in late spring, early summer. So you won't see this disease until it gets hot out, typically following bigger rain event. But you need to start preparing and make preventive applications, especially if you've had a history of this disease later in the spring and early summer. The symptoms, as you can see here, they're irregular orange patches or blotches. The roots, if you look at them, they're sizzled. So they're not translocating water or nutrients, and that's why you see a significant turf decline. There is a potential for, and I think there's a few folks down in the Southeast, Dr. Kearns, Dr. Joe Roberts, maybe even Dr. Horvath, looking at the potential for increased nematode activity because these plants are weaker, right? Nematodes don't feed on the really, really healthy plants. They tend to feed on plants that are going down. So some folks are looking at the potential for an interaction there with increased nematode activity. There are no signs. You're not going to find aerial mycelia with this. You're not going to find anything special. You're just going to find fried roots and orange bronze discoloration like you see in the photo there. So cultural controls, first, you got to improve drainage, get out there, make sure you're on a regular core cultivation program. Moisture management is really important as well. If you got waterlogged greens or you got greens that sit lower somewhere that don't lose moisture, those are always going to be more problematic than a green that sits up high or a green that has a sand-based root zone. Thatch management, again, aeration is going to help you out big time there, or even just verticutting, reduce that thatch. Push-up greens tend to be very problematic, so increasing sand content can help. You can do that by hollow tining 5/8 inch on your shorter spacing and backfill with sand. That'll help you out over time, as will a regular top dressing program. But those aren't things that are just necessary for Pythium root rot control. Of course, most of those are imperative for maintaining high quality turf. So we got another question here. This is probably the most important question I'm asking you today. So I'll be interested to see how you all answer because I got some information that might scare you into doing things differently.
Don't be scaring them, Brian.
Okay, not scaring them, giving them guidance to have a more effective application and a better outcome.
Okay, that sounds better. And I'm going to guess that this is one of those questions that may actually have a correct answer.
Well, there are no right or wrong answers. It's just experiential questions, really, what people do.
Okay, the school teacher in me coming out. Nice. And here we go, closing in 5, 4, 3, 2.
Wow, nice. All right, you're all promoted.
Ooh, do we get a raise too? I said that immediately.
Unfortunately, I don't make enough money to provide anybody on here a raise, but you all get a good job. You really, those of you in the 3-hour section, that's okay. Those of you down here in the 24, that's probably not that good. I'm going to speak a little more specifically about segue with that timing when I say this, but I mean, the first thing is you're spending a lot of money on fungicides, regardless of what product it is. If you spend a lot of money on it, the best you can do is water it in right away and get the most out of your money, because that's how it's going to perform the best. If it sits up in the canopy, right, wherever it dries is where it's going to start to stay. Okay, I'm not saying you can't move some of it down, but chances are after a couple hours, like 3 hours, after that, you're really not going to be moving it very far at all. So you spend a lot of money on this application. It needs to get in the root zone. For Pythium root rot or root dysfunction, go out there right away. Run those heads as soon as you're leaving the green. 14-day intervals, again, for root rot are going to be best. Using lower rates, particularly with segue. That's this plot right here, 0.45 fluid ounces on a 14-day interval. You can see a non-treated area here. That's pretty darn good for a 14-day interval on a lower rate. And Union's the same way. Just make sure short, tighter intervals are the best. Same thing's going to be if you're using something like mefenoxam or strobies. In the case of Pythium root rot and root dysfunction, strobilurins tend to be much more effective than they are on Pythium foliar blight. And phosphites, again, they're not always necessarily standalones, but phosphites are really, really good for helping control a variety of Pythium diseases. Preventive apps are important for greens with a history of disease. You want to start your applications for Pythium root rot if you have on a preventive program. You want to start them when the soil temperature at the 2-inch depth is 60. Sorry for those of you that could hear my dog losing its mind down there. That are 60 to 65 degrees Fahrenheit at the 2-inch depth. You want to apply it in a 2 gallon per thousand carrier volume. You can go higher than that. I would not go lower than that. An immediate post-application is essential with irrigation. You need to be greater than 1/8 of an inch, okay? If that's 3 turns for you, great. If that's 6 turns for you, great. If I don't know what you need to do, but just make sure you're getting out more than 1/8 of an inch of irrigation water following. Another question I'm asked all the time is, am I going to water it through the green, the root zone, if I put out too much water? The answer is no. You can't water any fungicide through the root zone. Dr. Kearns at NC State did a great study on this. I think Cam Stevens and Daniel Freund were his grad students that did it, but basically, even with a wetting agent, they don't find much of any active ingredient below 4 inches. So don't worry that you're going to overwater it if you're watering for root disease, because it's not going to happen just because of what the KOC value or the sorption ratio that pesticides have. This is preventive root rot control, again with segue, no pigments, no dyes, no colorants. This is the non-treated right here. This is segue, 0.45 fluid ounces. Again, phenomenal fungicide. If you have not had the opportunity to use it, just make sure you turn on that water as soon as you're leaving the greens. I know I'm not a big fan of the term curative because it's not curing anything. It's just stopping a pathogen from infecting so the grass can recover. But this was at NC State. This is with Union fungicide. You can see non-treated here, okay, not looking so sporty. This plot was 14 days after the treatment is when this photo was taken, exactly 14 days. So if you do run into a situation where you have disease breakthrough and you're looking for something, Union outperforms Terrazol. I will tell you that curatively for sure. So great option if you need something curatively. Here's data NC State put out a web page on controlling Pythium root rot with segue and Union. They basically titled it, "Are you piffed off at your Pythium root rot?" So if you're interested in reading that, it's something you can find externally. So the last one's going to be Pythium root dysfunction. I always jokingly like to say, I don't know what's wrong with my grass, so it's Pythium root dysfunction. A lot of people will say that it must be root dysfunction because they've sprayed everything else and nothing is working, right? Well, there's some specific things, and one of the first things I ask folks is, what type of greens do you have, right? Because if it's a annual bluegrass putting green, then it's not root dysfunction. Because like we talked at the beginning, certain pathogens only infect certain hosts. And in this case, Pythium velutum does not infect annual bluegrass. It infects newly renovated or aggressively managed bentgrass greens, typically less than 10 years in age. Okay, so this is a problem on bentgrass. There's no specific temperature requirements. It's even more obscure, if you will, when the infection process occurs. Typically, it happens when temperatures in the soil at the 2-inch depth are between 50 and 75 degrees Fahrenheit, and that can be anywhere into the fall, winter, and spring. What you will see, and typically you'll see this again when you start to get warmer conditions in the summer, and I'll explain why in a moment, but they're smaller patches less than 2 feet in diameter. And the reason you see them in the summer is because it's the roots can be white, but they lack root hairs, which reduces their water uptake, which is why you start to see these symptoms. There aren't any signs. You're not going to find mycelia. You're just going to see these off-colored patches with no root hairs. And this is from Lee Butler at NC State. He tweeted this out a few weeks ago, talking about how you can pull a plug out. The roots are nice and long, but when you hold it up and all the soil drops down into this bucket below, it's because it lacks root hairs and it's not able to hold on to that soil around it. Cultural practices for controlling Pythium root dysfunction, moisture management, try not to overwater, go out there and do more hand watering if needed. Reducing stress and increasing mowing height. I know nobody wants to hear the following or the latter there, increasing mowing height, but if you are having problems, that's one way to help out. And obviously adequate fertility. You don't want to have under-fertilized plants. Again, that is nitrogen, and I know that the trend in the industry is to do as little fertilization as possible. But if you do run into issues, increasing mowing height and increasing fertility just a little bit can really help out on a number of different things. Controlling dysfunction with fungicide control, and I would ask that if you do think you have dysfunction, send it to an accredited university to have them confirm that diagnosis. But if you do, forget this first point because that's not true for this one. I left that in accidentally from the last slide. But you want to use things like Segue or Union on a 21 to 28 day interval at the higher rates. Same thing with your Strobies, Fame, Heritage, Insignia. They're great rotational partners. Just use them at the higher rates on a 21-day interval. Banol and Signature is very helpful with this particular disease. Phosphites can also help out. Just make sure that when you're using premixed products or our products that you're, or single AI products, I should say, that you're not using any specific mode of action more than twice, right? So if you wanted to use Segue and Union around each other, you could use Segue, you could use Union, then you could use a Strobi, right? But your next application really shouldn't be anything that includes a Strobi if you used Union and then a Strobi, okay? Because you don't want to make 3 applications a row with that same mode of action. Preventive apps are important. Curative apps, though, are effective. Once you start to get it, though, if you do have this, I would recommend that you get on a preventive program moving forward. Initial apps in the fall or spring, once soil temperatures drop below 75 Fahrenheit, would be when you want to make those. Again, higher carrier volume is good to get a little more water down on it, and immediate post-application irrigation, again, is essential. I can't speak for all products, but I can say for Segue and Union, you need to water them in pretty quickly. So a review here, Pythium blight, this can affect all species. Specific requirements on cool season turf, it's problematic on Bermuda grass during cooler, wet conditions. It causes widespread death of turf or blight in a short period of time, and preventive apps are the only remedy besides seeding and reseeding, and fungicides should be left on the foliage. Pythium root rot, irregular yellow-orange patches or blotches that reduces translocation of water nutrients. The roots will appear sizzled or shortened. Symptoms develop during hot conditions following significant rainfall events. That's why you typically see this start to pop up in June, July, and August. It's problematic on bent POA greens with poor drainage, though it is also found on ultra-dwarf Bermuda grass greens quite commonly as well. Fungicides must be watered in order to achieve control. And with dysfunction, you got those small patches. They're going to be much smaller than what you see than the larger irregular areas with root rot. And that's because you don't have any root hairs there. It reduces translocation of water nutrients. You can see that soil fall off. That's not the only way to diagnose it, but that is a helpful indicator. if you see longer roots but soil still falling out. It's typically specific to newly renovated or new bent grass greens, and fungicides must be watered in, just like with root rot, in order to achieve control. Root dysfunction, I could put any of the Pythium diseases here. There are a lot of great fungicides from different groups, Subdue, Segue, Fame, Banol, Union, Signature, Insignia. They're all great. They all have their utilities and which type of Pythium you're trying to control. But make sure that you rotate through these fungicide groups because, as I talked about in the beginning, Pythium diseases are caused by oomycetes, and you just don't have the spectrum of different modes of action or different active ingredients in the turf industry at that time where you can get control if you start to see resistance with some of these. So it's really important, which we already do with Pythium blight with mefenoxam. So just make sure you rotate whatever you're doing, and product placement again is critical depending upon the location of the pathogen you're trying to control. So with that, I appreciate your time. I appreciate y'all answering the questions we had. The information on educational credits is here. And you're welcome to email me if you have questions. You're welcome to follow me on Twitter. I post a lot of stuff, kind of current event type things. Also, different products we have, how they're performing in research trials. And I'm happy to help you out in any way that I can. If Pythium's a problem for you, or other diseases, or even weeds. And to learn more about PBI-Gordon stuff, Segue, Union, of course, things like Speed Zone, T-Zone, and Q4, please go to PBI-GordonTurf.com. And with that, Lisa, I will hand it back to you.
Thanks, Brian. Lots of good information there today. As he has indicated, and you see on this slide, PBI-Gordon has arranged our external education points. We appreciate that. You will go to the GCSA website and use the 999 code 238231521. And anyone who might be listening to this as a recording in the future, make sure you put the date you're listening and not today's original date. If you have questions, now's the time to raise your hand or type those into the question answer box. We'll be happy to take those. I'll also mention that we have a couple other live webinars that PBI-Gordon is partnering with us, and Brian will be presenting disease control with DMI fungicides as part of a fungicide resistant management program on September 21st. Almost September, folks. And then Jody Cunningham is going to talk about recruitment in October as part of this series. Not seeing any questions, so I'll put one up. Did you see this event on the GCSA Now app? The app can help you with different things, including the calendar of live webinars. You can also see your chapter events. Golf Championship registration is open. Will be limited seating, or I guess it's not really seating, is it, Brian? Well, we're seeing no other questions here today. Brian, you have any closing remarks for us?
Just, if you're struggling through with the weather, hang in there. It is almost September, like Lisa said, and things will get better. So again, if I can ever, I appreciate your time, first of all, for today. And I appreciate those of you listening. And if there's anything I can do to ever help you out, please don't hesitate to contact me.
Great. Well, I thank you so much for your time and energy. I want you to all stay safe, especially with some of the storms and fires that are going on out there. And we'll see you online again soon. Have a great day, everybody.